Chapter 3, Part 2. Third emergent property of water is frozen form of water is lighter than its liquid form. Ice is the frozen form and water is the liquid form. And the hydrogen bonds are there between water molecules, whether it is liquid water or ice. And as you can see that there are more water molecules in liquid form of water compared to the solid form of water. What happens in the liquid form is that these hydrogen bonds are breaking and reforming continuously, and because of that more water molecules occupy the same region, whereas the water molecules in a solid form, that is ice, they are distanced and these hydrogen bonds are constant because the temperature is really low. They're not breaking and reforming, so they are spaced out. Because of this, there are fewer molecules. Fewer molecules means comparatively lesser mass. So ice is lighter than liquid water. Water in liquid form is heavier compared to its solid form. Usually we have the understanding that solid form means it is heavier. Solid, heavy, they both go together. But make sure that you're watching out for these words in the test. And the reason why water floats in its solid form over its liquid form is because of this less mass. Anything that has less mass will float over the heavier mass thing, right? So in polar regions, this property makes a huge difference. In winters, when the temperatures reach below minus, the top layers of water bodies, oceans, and all the water bodies in polar regions, they solidify and they form thick ice. Because of that, the water underneath it is able to stay in liquid form, and because of that, the living organisms are able to survive even if the temperature has gone way below zero. And because of this, the polar bears and other animals in polar regions, they're able to stay on top of that ice and are able to get their food and are able to survive. So that's the third property of water. Ice floats on a liquid water. Coming to the fourth property, water is a versatile solvent. That means it can dissolve many substances. Water can dissolve alcohol, salt, sugar, and many proteins. What water cannot dissolve, how much ever versatile it might be, and that is oil. Water cannot dissolve oil, and that's the nature of water. Water is polar, that means it has charges, whereas oil molecules are non-polar, they do not have charges, so they do not like each other. But anything which has partial charge, little charge, absolute charge, such as salt and alcohol, which has polar with polar molecules, polar covalent bonds, all these substances are soluble in water. So when two things mix, two chemical substances mix, then it is called a solution. And in solution, always one which is dissolving, the other one which gets dissolved. So the terms for them are solvent and solute, and mixture of these two will be solution. Remember, solution has both solvent and solute. And if the solvent happens to be water, then it is called aqueous solution. Remember, water is not a universal solvent, it's a versatile solvent. That means it can dissolve many substances, but not all. Whenever you just drop a teaspoonful of salt in water and come back and check on it after some 15-20 minutes, you can see that the salt disappears from the bottom of the beaker. Why does it happen, and where did the salts go? Remember, sodium chloride is the chemical formula of salt, and sodium and chloride ions, they separate from each other very quickly when they are in polar solutions such as water. And the reason why they separate is because sodium ion, which is cation, remember, positively charged ion, is surrounded by water molecules, because oxygen of water molecule is attracted to sodium ion, which is positively charged. So many water molecules surround sodium cation, whereas chloride ions also have water molecules surrounding them, but remember, the hydrogen of water molecule will face chloride ion. So one of the test questions is when water molecules surround an ion, and if they are facing towards the ion with their oxygen, then what is the ion? Is it cation or anion? If oxygen side is facing them, then it must be cation. That means positively charged ion, right? So you can make up a question like that for anion. And this structure is called hydration shell. When an ion is surrounded by many water molecules, this is called a hydration shell. This purple thing here is what is a protein molecule called lysozyme. Lysozyme, not lysosome. Remember, lysosome is an organelle in cell. No, this is lysozyme, an enzyme made of protein. And this protein is made of many amino acids. Many small molecules together make this big molecule called protein. This big molecule called protein has a few polar parts and many non-polar parts. That means they are not attracted to water. But still, lysosome, no, I'm sorry, lysozyme is very well soluble in water because of its polar parts. So the tiny polar parts in this molecule, they attract water, and that is why it dissolves in water. You know where this lysozyme protein is found? It is found in our tears. So our tears are not just salt and water. It also contains an enzyme called lysozyme, which is going to protect our eyes from bacteria. If any bacteria comes in, then it will simply destroy bacteria. That is how our eyes are protected. That is why you should have a lot of tears in our eyes, not tears rolling down, but the tears, because it is a mixture of water and many other substances which help our eye and keep our eye safe. Coming to the next concept, mole and molarity. Before we go to this concept, we have to make sure that we review the 4 properties of water that made life possible on planet Earth, and they are cohesive behavior. Remember, attraction between water molecules, which helps in transportation of water from their roots to all the aerial parts. which is required for their existence. Second property is ability to moderate temperature on planet Earth. Because of that, the temperature is regulated and we are able to survive. And third property of water is water in solid form is lighter compared to its liquid form. Because of this, polar region animals are able to survive even in winter when the temperature is below zero. Last property is versatility as a solvent. It can dissolve many substances, and because of that, there's protection in our eye. There is food available for bacteria and many animals in water bodies such as lakes, rivers, oceans. So that is a review of what we studied so far. And coming to the next property in the same chapter is mole and molarity. These are actually the chemistry concepts, but we have to know what it is in order to successfully understand how the solutions are made in a lab for carrying out experiments. So first we need to know what is Avogadro's number. Avogadro's number is equal to 6.02 times 10 to 23. What is this mole? Mole is number of molecules are measured in this mole. What is mole? Mole is these many molecules, 6.02 times 10 to 23 molecules of any substance. A substance such as hydrogen is much lighter compared to an atom lead. Okay, and lysozyme, which is made of many atoms, is much heavier compared to water, whether it is heavy molecule or lighter molecule. But number of molecules, if they are 6.02 times 10 to 23 molecules, then it is 1 mole. This is a way that scientists measure substances out in order to make solutions of fixed ratios. So in order to calculate 1 mole of a substance, it is not possible for us to pick out that many million molecules, that many trillions of molecules, and place them in a beaker or a container. We cannot see molecules to count them. So how will we know that these are the molecules, these are the number of molecules that we are able to aliquot? This is calculated using a very simple method. So to measure out 1 mole of any substance, it could be glucose, it could be sucrose, it could be anything. In order to calculate or measure out that much of a substance, first we have to calculate the molecular mass of a substance. What is molecular mass? It is mass of all the atoms in a molecule. Mass of all the atoms in a molecule. So for example, in sucrose, once you know the molecular formula of sucrose, then you calculate its molecular mass. C12H22O11 is the molecular formula of sucrose molecule. Just like H2O is molecular formula of water, like that, C12H22O11 is the molecular formula of sucrose. That means in sucrose there are 12 carbons, 22 hydrogens, 11 oxygens, all bonded together by covalent bonds, making one sucrose molecule. Sucrose molecule is nothing but sugar molecule. Molecule is so small you cannot see. I'm not talking about the sugar crystals. I'm talking about sugar molecule. So in a sugar molecule, these many carbons, hydrogens, and oxygens are there, right? And you also know the molecular mass, not molecular mass, mass number of each element as well. Mass number of carbon is 12. Remember C612, small number is atomic number, big number is mass number, like that. C, which is carbon's mass number is 12. So 12 atoms of carbon and 12 is its mass number, so you multiply them. Plus hydrogens, there are 22 of them and mass number of hydrogen is 1, so you multiply 22 with 1. Plus 11 oxygen atoms multiplied with mass number of oxygen, which is 16. So you multiply 12 with 12, 22 with 1, 11 with 16, and then you add them all up. Then the total will be 342 Daltons. Remember, you have to multiply each one which is in the parenthesis first, and then add them all up. And then you get the molecular mass of sucrose. And it comes out to 342 Daltons. And in order to measure out 1 mole of this substance, you have to simply take a sugar bottle, which is powder in form, sucrose, and take a little weigh board, place it on the measuring scale, and with spatula start scooping out little by little and putting it in the weigh board. And whenever the weighing scale reads 342 grams, 342 grams, that is when you know that you have measured out 1 mole of the substance. 1 mole of a sucrose weighs 342 grams. Why? Because 342 Daltons is the mass of 1 molecule. So in these many molecules, there will be the mass of, or these many molecules will weigh, and its mass will be 342 grams. So that is how you weigh out 1 mole of sucrose. How to make 1 liter of 1 molar sucrose solution. This could be one of the questions on the test, either in the final test or in your competitive MCAT exams. These kind of questions will not be there in your unit test, which is coming up, but definitely will be there in competitive exams. And if you are taking nursing as your major or any other advanced biology classes, you definitely need this concept. So how to make 1 molar sucrose solution? You have to measure out 342 grams of sucrose, because that is 1 mole of sucrose, and then add 500 milliliters of water to a graduated cylinder which says 1000 mils, and you pour in the 342 grams of sucrose that you measured out and mix it up. After you mix it up by stirring, you can add more water, and do not add 1000 milliliters of water, because 1 liter is 1000 mils. No, remember 342 grams of sugar or sucrose will take up some volume, and you cannot add that much of water. So you have to add only 500 mils of water, add 342 grams of sucrose, mix it up, and then start pouring water till it reaches 1000 mils line here. So that is how you make 1 molar sucrose solution and a volume of 1 liter. So make sure that you repeat this part of the PowerPoint, the video, and learn how to make 1 liter of 1 molar sucrose solution, and how to calculate molecular mass of sucrose. And if you want more practice, then you can do practice questions of your own from the end of the chapter. Coming to the pH concept, What is pH? Many times you might have heard there's pH of your blood, water has pH, and soil also has pH, right? So in order to understand what is pH, what exactly is pH, what are chemists and biologists and scientists looking for when they're saying pH, right? What pH means to a layman, or biology students who are trying to understand the interesting concepts of biology. So in order to understand that, first we have to know one thing, that is water molecules, which are made of one oxygen and two hydrogen atoms, they do not stay as a group of three atoms always. Sometimes what happens is they dissociate, and one of the hydrogen atoms, it just falls apart as a hydrogen ion. And because of that, the water molecule which loses one hydrogen atom, it becomes hydroxide ion, OH minus. And that hydrogen ion which dissociated from the water molecule, it cannot stay by itself in water. It gets soon attracted to another water molecule, and association of three hydrogen atoms with one oxygen, this is called hydronium ion, and it has one positive charge. So there are hydroxide ions and hydronium ions, these oppositely charged ions in water. And if you add any acid or base, then the amount of hydronium ions and hydroxide ions, that will be disturbed. And because of that, water does not remain neutral anymore. It either becomes more positively charged or more negatively charged, because either hydronium ions are more or hydroxide ions are more. So another thing, this process of dissociation of water molecules, it is 1 in every 554 million. Though it sounds rare, remember, in a bottle of water there's so many trillions and gazillions of water. So though it is neutral, they're equal in number. When acid or base are added, then it quickly changes the pH of water. So what exactly is an acid? Acid is a proton donor. A base is a proton acceptor. So acid is any substance which will increase the hydrogen ion concentration of a solution. That means it is providing, or it is making hydrogen ions. And just like how we talked about dissociation of water and hydronium ion being made because hydrogen ion gets dissociated from water molecule, same thing, acid, when it is added to a solution, it will increase hydrogen ions, which is H plus, and that is why it is very reactive, and it keeps on donating protons, and such a substance is called acid. Bases are equally harmful as well. I wouldn't say bad, but they are harmful as well. So a base is a substance which will reduce hydrogen ions because it is quickly accepting the hydrogen ions because it has more hydroxide ions. As simple as that. So acid is a proton donor and base is a proton acceptor. You have to know this. You have to remember that pH scale range is 0 to 14. Acidic solutions have a pH of 0 to 6.9. Neutral solutions are 7 and 7 only. Basic solutions have a pH of 7.1 to 14. Look at this pH scale range. You can see pure water without any contaminants would be pH 7 because it has equal number of hydronium ions and hydroxide ions. Whereas in acidic solutions, there are a lot of hydrogen ions which are reactive, and If they're more, then it is really harmful to us. And same thing, basic solutions have a lot of hydroxide ions, which are again more reactive, and if there are too many, then they are harmful as well. Remember, acids are equally bad as bases. Don't think that bases are okay and acids are only bad. It's not true. Both acids and both strong acids and both strong acids and both I'm sorry, both strong acids and bases are equally harmful. So this is a pH scale 0 to 14. The difference between one digit and the next digit is not 1. It is actually 10. Why? Because pH scale is a log scale. Log means base 10. So the difference between pH 1 and pH 5 is not 4. pH 5 and pH 1, they're different from each other. Not 40, not 4, not 40. Then how much? You have to multiply 10 times 10 times 10 times 10. So it is not even 400. It is 4 zeros, so it is 10,000 times. So battery acid, which is pH 1, is 10,000 times more stronger than a solution which is pH 5. Remember, rainwater is acidic, and our urine is also acidic. That is why it is called uric acid. Our household bleaches and oven cleaners, they are very harmful. Milk of magnesia that we drink in order to pacify the heartburn, that is a base, and it is anywhere between 10 and 11. And the difference between solution which is pH 10 and pH 12 is not 2, it is not 20, it is 100. Why? You have to multiply this 10 with this 10. pH 10 solution is 100 times less basic compared to pH 12. One more fact, a solution with lowest number in pH scale is strong acid, very strong acid, and weak base, whereas a solution which has highest number, that is 14, is very weak acid and the strongest base. So you have to apply that concept to all the solutions, whichever number it might be. So let's do one of the pH problems. If a solution's hydrogen ion concentration is 10 to minus 7 moles per liter, what is the pH of the solution? pH formula is minus log square bracket H plus square bracket. This is read as negative logarithm of hydrogen ion concentration. Hydrogen ion is H plus, concentration is represented by square brackets. Concentration is nothing but how many of them are there. The question here is saying that hydrogen ion concentration is 10 to minus 7 moles per liter. So what is pH? If you apply 10 to minus 7 and log, look at log scale, then it will be minus of minus 7, which will be 7. The simplest way to do this is, as soon as you see that hydrogen ion concentration is 10 to minus 7, simply take that number. Don't consider that negative. There is no negative number in a pH scale range, right? 0 to 14 only. So the solution has a pH of 7 when hydrogen ion concentration is 10 to minus 7. I know that we talked about mole, molarity, Avogadro's number, how to make molar solutions, and pH scale range, and the differences between pH scale. So whenever I do this class in my uh, in my face-to-face sessions, I always ask for the muddy point. I give out sheets of paper and ask students to write out what is not clear. And I always get the request after this point that this chapter has been very easy, but we would like to do more um, problems on pH and other concepts that we had just covered. So let's take some more problems. Um, if hydrogen ion concentration is 10 to minus 9, then the pH is simply 9, right? As simple as that. Answer is 9. What you have to do is, as soon as you see hydrogen ion concentration, all you have to do is write down the number, whatever is the power number, just write it as pH. It's not minus 9, it is 9, because minus of minus 9 would be 9. Okay, and coming to next problem. What if they give you hydroxide ion concentration, not hydrogen ion concentration, but in the problem they said hydroxide ion concentration is 10 to minus 9. Then you have to do a little math, a little more math, not just carrying that number over. In this case, pH is not 9. In this case, pH is 14 minus this number. Why 14? 14 is the largest number on the pH scale range, remember? So you have to always subtract this number from 14 to get pH. So 14 minus 9 would be 5. So answer is 5 in this case. Again, remember, if the pH needs to be calculated from hydroxide ion concentration, then you have to do the math, that is 14 minus 9, whatever is hydroxide ion concentration. If hydrogen ion concentration is given, then you simply take this number directly for pH. Coming to a little complex question compared to the previous ones. Previous ones were very simple, right? For solution A, hydrogen ion concentration is 10 to minus 9 moles per liter, and solution B has hydrogen ion concentration of 10 to minus 12. So can you calculate what is the pH of solution A and pH of solution B? pH of solution A is 9, right? And pH of solution B is 12. Simple. But the question is, which solution is more acidic? You know that both pH 9 and 12 are actually bases, right? Because we learned that the pH scale range of bases is 7.1 to 14. But here the question in the test is asking you to figure out which one is more acidic. So, which one is more acidic? Remember we said the lowest number in pH scale would be a stronger acid. So solution A is more acidic compared to solution B. So answer is more acidic solution between A and B in this problem is actually A. Another kind of question from the similar information would be, solution is how A is how many times more stronger than solution B. So you have to calculate the difference. What is the difference between 9 and 12 on a pH scale? 9, 10, 11, and 12, right? So remember, a 10 times 10 times 10 will be 1000. 10 times 10 times 10 will be 1000. So solution A is 1000 times more acidic than solution B. That will be the answer. If you want to say the same thing the other way, if they were asking which one is more basic and how many times, then you would say solution B is more basic than solution A. And if they ask you how many times, then again the same thing. Solution B is 1,000 times more basic than solution A. Okay. Next question. This is a little complex, I would say. They said household ammonia has a pH of 12 and bleach has pH of 13. So which of the statement is true? The correct answer is ammonia has 10 times as many hydrogen ions as the bleach. Remember, lowest number is more acidic compared to the largest number in the problem. So small, big. Small number means more acidic and big number means more basic. And the difference is only 10 because, 12 and 13 are next to each other. Coming to the next concept, what is buffer? A buffer is a substance made of acid-base pair. We have buffer in our blood. That's the reason why, though we drink a glass full of orange juice, which has a lot of hydrogen ions, our pH is not thrown off. Our blood pH still is going to remain the same, and we are quite healthy and we feel good after drinking orange juice. And it's because of buffers. What buffers do is they regulate the pH, and because of this we are able to survive without any problem, though we are ingesting a lot of acidic food and a lot of basic food sometimes. And, acidification concept is very easy to understand when you read from the textbook. Make sure that you read it and also practice mole and molarity and pH problems for the test. So that's it.